Hello.
How are you?
I'm fine. How are you?
I'm here.
Are you at work?
No, I'm kind of like trying to bring my hair down so I can be on camera. Running at the last minute. Okay, all right.
All right.
Hold on.
I'm going to give it just another minute or so to see if anybody else shows up, because I know it's kind of an odd time of day.
Okay. Gotcha.
And just cut to the chase, be short, quick, and direct, and say thank you very much.
All right.
You know, because they asked you to do that, and they asked.
All right. I don't know if we're going to get anybody else or not. So I'm just going to go ahead and launch into the review. So this is going to be just a pretty basic review. Going to do a little PowerPoint clicker Q&A, basically what we got here. So let's get started. And it's all on you. This is just you and me. You're representing everybody.
Oh no, don't do me like that.
Well, I help. I never leave you out there too long. I walk you through stuff.
Yeah, but this is a lot of stuff we walk through, so I'm ready. I'm like 3 exams coming up Sunday. Like my
Yeah.
head spinning right now. I don't know if
Yeah.
I'm coming to be honest. So hey, whatever.
I hear you. And it's amazing, you know, once you've done it, you think, how did I do that? But
Exactly.
yeah, you do. You do. I know that when I was going through my grad program, before I even got to campus, I worked for a chiropractor. And she said, let me tell you how it's going to go for you, Rebecca. She said, your first few terms, you're going to be studied and well nourished and gotten a lot of sleep, and you're going to show up there, you'll have your pencils, you know, all laid out and everything, you're going to be on it. And she goes, and somewhere around 34th term, she says, you're going to get worn out and you'll show up and you'll have bags under your eyes and you'll be on 2 hours of sleep and 8 cups of coffee, and maybe you have a pencil, maybe you don't. And she says, by the time you're in the last third of the program, you'll walk in and say, we got an exam today? Okay. And then you'll take it and you'll do just fine. So I understand. We've all done it. We've all done it.
Okay.
All right. So, and I know it's frustrating because you want to do really well and, you know, you're pushed so much that you might not be doing that well, but that's it. We've all done it. And it seems to be a system that works and people learn. So. All right, so this is from USLO 8.1. So if we're discussing all the chemical processes in the body, what are we talking about? Is it your metabolism? Is it catabolism, anabolism, digestion? We're talking about everything the body could possibly do.
Metabolism?
Yay! Yes. I see students. Well, the reason I make a big deal is that students get that wrong on quizzes and exams all the time. It's like that should be a no-brainer.
Right.
Yeah,
Okay.
all the processes, the breakdown, the rebuild. That's all of them. That's all of them. Yeah, perfect. All right, off to a good start. All right, taking a large molecule and breaking it down into small molecules. What do we call that?
Catabolism.
Yeah, it is. Yeah, catabolism. Yep, good job. Yep. I always have to think them through, and I get them, even now I get them
building up, and catabolism is breaking down, right?
Exactly right. Anabolism, I think anabolic steroids, you know.
Okay.
Not that I take those, because I don't. Never have. All right, when small molecules are joined together to create the big one, that process is?
Anabolism.
Anabolism, yeah. We're getting all these definitions out of the way right away. All right, so let's see. This vitamin is needed for calcium absorption. I've got 2 questions like this.
Calcium absorption.
Yeah.
I want to say, I don't want to say, but is it D?
It is
Right.
D. Yeah. Yeah.
All right.
Yeah. I could see it on the tip of your tongue, and I'm like, yeah, that's it. It's the D. Yeah, exactly. And I have another question. I didn't realize that this question was in here. I created another one just now, but it's a better question. And now you'll be prepared for that one.
Okay.
All right. So which of the following vitamins can be stored in the body?
A and E.
Exactly. Those are the only two fat-soluble vitamins that we have listed there. Vitamin K is a fat-soluble vitamin, but for some reason we don't store that.
Okay.
Yeah. Yeah. So your fat solubles are A, D, E, and K.
Okay. Right.
Yeah. Yeah. But we don't store K. Don't know why.
Okay.
All right. This vitamin aids in vision.
C
Not directly.
or A?
Exactly. Yes. That's why they say rabbits have good vision, is because
Okay.
they eat all those carrots with the vitamin A.
Vitamin A. Okay. Okay.
Yeah. Yeah. Vitamin A, carrots. They were, yeah. I was always taught that rabbits have
You got
good
me on
vision.
a hot seat. I'm sweating.
I know it's different when you're on that side of things,
Right. Ooh, okay.
but you're doing well. You're doing well.
Thank you.
All right, let's see. And this is the best way that the best way that adults learn is by being quizzed like this. This is the best way. All right. So this vitamin is needed to produce red blood cells.
I'm on the fence between B12 and vitamin K.
Ah, so your thinking is not altogether wrong. And in fact, it is B12.
Okay.
We need B12, but we need vitamin K also related to a blood activity, specifically clotting. That's what you were thinking, wasn't it?
All right. Yeah. So I was like, it's one of them. Okay.
Yeah. So K is needed for clotting and B12 is needed to make red blood cells.
Okay.
Good job. Good job. Yeah. That's good association. You just needed a little point of clarification. So we've already been through the digestive system. What is in the stomach that aids in vitamin K? Do you remember that? Something that the stomach makes.
Is that the intrinsic factor?
Yes. Wow. Good job. Yeah. Yeah. Look at you.
Okay.
Yeah. Good job.
All right.
Yeah. I'm so pleased. All right. So pleased.
Oh my God.
I don't mean to stress you out.
You stressing me. You stressing me. I'm like, it's just
I'm
me and you here.
Well, yeah, that's always, yeah, because now it's like you're in the spotlight, so that's always stressful.
Right.
Yeah. But I'm not scary. It's just that you're being quizzed, right?
Exactly.
I'm not scary. Okay, good. I don't want to be scary.
No, you
always
not
want to be. Okay, good. Yeah. Although I had my attorney tell me one time that I could be scary.
I can imagine, but you're not scary though.
Yeah, I guess I can be. All right, so let's see. How about this
we all
one?
can be.
Yeah, I was just surprised. I never thought of myself as scary, and I was having some business issues with. I don't want to get into a lot of detail, but I was having some business. I was being taken advantage of, and I called my attorney, and I was like, "What?" And he goes, "Stop, Rebecca." He goes, "You're scary. You don't even know it." And I went, "Really?" He goes, "Yeah." And I did. I realized, I thought back on it. It's like I have scared him a time or two, and I was unaware. And so he told me, he goes, "Just go get your money. Go over there, tell them you want it, and they'll give it to you." And he was right. I showed up. I was very nice, but I scared him.
Okay.
I know. It's like, how did that happen? Anyway. All right, let's see. A low-fat diet may make it difficult to absorb which vitamin?
A low-fat diet may make it difficult to absorb which vitamin. Low-fat.
You want a hint?
Yeah, would it be, it's low fat, so you need AD.
Yep,
Okay.
yeah,
All right.
it's A.
It's A. It's okay. All right. I'm like,
Yeah.
think about that one too.
Well, so in the world of chemistry, you need, like dissolves like.
Okay.
So we've got water everywhere in our bodies.
Right.
But if you're eating a low-fat diet, it might make it difficult for your body to absorb fat-soluble vitamins.
Gotcha. Okay.
So that was why that was your hint. So
Okay.
of all of those, hopefully you recognize that B is not fat-soluble, neither is C. In fact, none of the B's are fat-soluble. The one that's different is A.
Okay.
It has to do with the fat. Yeah. So I thought I heard you say A.
I did.
Yeah. So you're doing good.
Okay.
Yeah. All right. Let's see. What's another one? Oh, sorry about that. How many vitamins? This is a good question. How are many vitamins used in the body? The choice, I mean, they're used for a lot of things, but are these choices down here? What do you think?
I want to say as fuels, and it's like I'm stuck between fuel and coenzymes.
Well, the correct
So-
answer is coenzymes.
Okay. All right.
Yeah. So we don't use vitamins as fuel.
Fuel, right.
use-
Okay. Food.
We use carbs, proteins, and fats.
Okay.
Yeah. Yeah.
All right.
So that's how you would have probably thought through that one. Yeah.
Okay.
Only your macronutrients, carbs, fats, proteins are used as fuel. Everything else gets used in different ways. Yeah.
Okay.
Yeah. And I just threw that one in at the last minute. I'm like, I didn't ask anything about vitamins and coenzymes.
Okay.
All right, let's see. What else? Oh, here's a good question. Vitamin D3 is converted into this, which is needed for doing this in the small intestines.
Now I'm stuck. Vitamin D3 is converted to.
Well, let's do a little.
Okay, go ahead.
Let's do
Calcium for calcium absorption, or
okay, so you're good with calcium absorption, right?
okay, so would it be for sodium? Or no, calcium absorption, yes, but I don't know which one.
Ah, okay. So it's actually the calcitriol.
Oh, that's what I said. Okay, so it's calcitriol. I said calcitriol. I'm sorry.
Yeah, calcitriol. I'm going to double. I
That
want to
was a
say
total guess. I don't know.
yeah, and I can't remember where that showed up. I'm going to do just a real quick double check to make sure. Oh, here I am again. I've got like 18 slides, 18 tabs open. I always do that. I would make it a point to know that.
Okay, I'm gonna write that down.
I would, because that was on a pre-exam.
Okay.
Yeah. Calcitriol. Just want to double check myself. Calcitriol is the active form of vitamin D. Yep.
Okay. All right, and is needed for calcium absorption in the small.
Right. Yep. Yep. All right. So I'm going to resume my share. So the short story of what happens with vitamin D is that we start making it in the skin when the skin is exposed to sun.
Mm-hmm.
And then at a particular stage of its development, it leaves the skin and it goes over to the kidneys. Excuse me, it goes over to the liver where it gets converted into calcidiol.
Okay. Converted into the liver. Converted in the liver as calcidiol. Okay.
Right, right. Now it's not ready to go yet. It has to go over to the kidneys, where then the kidneys will turn it into calcitriol.
I was saying, so the kidneys turns it into calcitriol. Okay.
Right. And then the reason why we have the kidneys do that is because we've got a low blood calcium level issue.
Okay.
And so we're trying to pull calcium out of every available source in our body, such
Okay.
as anything that might be in the small intestine,
Okay.
anything that might be in the filtrate of the kidney,
And the bone, is that right?
and the bone. Right.
Okay.
Now that's all of that's under the influence of a hormone.
Hormone, calcitonin, I guess. Is it?
Calcitonin tones the bones. It actually
Okay.
puts, who's the other one? Who's the one that does just the opposite of calcitonin?
Oh my God. I studied this for so long. I should know it. Like, it's calcitonin and
This one is the agonist of calcitonin.
oh my God.
Starts with a P.
No, it's not potassium.
No, that's a mineral.
Shoot. Oh my goodness. What is it?
PTH.
Oh,
Parathyroid.
Parathyroid. Okay, parathyroid.
Yeah, parathyroid hormone. Yeah.
Okay, gotcha. All right.
So all of that's under the action of parathyroid hormone.
Gotcha.
Yeah, good job. Yeah, I'm pulling stuff from, like,
AMP1, way.
oh yeah, anything.
All
Yeah.
right. So she's making me sweat over here right now. She's making me sweat. I'm the only one on here. And I gotta get this stuff right. All right.
All right, let's see. Taking protein and turning it into glucose. What do we call that?
It's not glycolysis.
Nope.
No, it's not that. Fermentation.
So not that one.
Right. It's not that one. I don't think it's fermentation.
Nope.
And you said it's taking protein and turning it into glucose. So would it be gluconeogenesis?
It would be, yeah.
All right.
Yeah.
And the only reason I went with that is because glucogenesis is telling me that it's the start of glucose, but this thing is telling me that it's taking a protein and turning it into a glucose. So
Exactly.
neogenesis, kind of putting it together, but
That's exactly the way you should have thought of that. Yeah, because the neo tells us it's a new glucose. It's glucose from a non-glucose source. Exactly. Good job. That's how you get good. That's how you get good scores. Think it through.
Let me get you 100.
That's right. We want 100, don't we? We want 100 out of this. All right. How many ATP molecules can one glucose produce in aerobic respiration?
Oh, you went over this.
Yeah, I did.
In one round?
So it's not one spin of the cycle.
All right.
It's
so,
everything.
All right. So that means I want to say 12 or 2. So I don't know.
Right.
Help me out on this one. This is like
I will help you. Yeah, this is when we get into the Krebs cycle and the electron transport chain. Yeah.
Okay.
That was the first thing I was going to say. Can you tell me what we mean by aerobic respiration? So that's once we've gone into the Krebs cycle and the electron transport chain, and that's where we have the biggest payoff. So Krebs cycle only gives 2, but the electron transport chain is going to give us about another 30. So we end up with anywhere around 32 or 34 out of the entire processes that make up aerobic respiration.
Okay.
That's your biggest ATP. Got weird things buzzing over there. Don't know what that's about. That's your biggest ATP producer. Aerobic respiration.
Produce, yeah, okay.
All right.
So it's produce in aerobic.
Yeah.
And that's the one that requires oxygen because it's aerobic, right?
Exactly, right. Yeah. Yeah. Right. And the way that we make most of that ATP is going to be through those high energy molecules that I kept talking about. NADH, remember that?
Yeah.
NADH, yeah.
Yeah.
Through all of that. Yeah. Yeah. So reviewing it, glycolysis will make 2. Actually, glycolysis makes 4, but we use 2 to get the process started. So it nets 2.
Okay.
The Krebs cycle makes 2.
That's what I was thinking of. Okay.
Yeah, Krebs cycle makes 2. But the other part of aerobic is that electron transport chain, also called oxidative phosphorylation.
Okay.
I'll type that on here. Oxidative phosphorylation. Phosphorylation. There's a Y in there. Phosphorylation.
Okay.
Also known as the electron transport chain. Yeah, that gives you the other, I don't know, 30-ish.
Okay. All right.
That clear?
Yeah, clear.
All right. Fabulous. Okay. All right. So, and yeah, this is review from what we just finished yesterday. So yeah, I'm happy to explain.
All right.
So which process is defined as breaking down glucose into pyruvate?
Breaking down glucose to pyruvate, which is pyruvic acid.
Pyruvic acid, yeah, right.
I know glycolysis has to do with water breaking it down. So glycolysis, no. Oh,
No,
okay.
not water, but yeah, you got that right.
You're breaking down glucose, glycolysis.
Right.
Okay.
Exactly. Yeah, that's it.
Into pyruvate. So
Yeah.
I'm thinking of hydrolysis and glycolysis all together. All right.
Ah, yeah. So
Okay.
the operative word is lysis.
Right. All right. So break it down. So
Right.
would that be the correct answer?
Yeah, glycolysis.
Okay. All right. Gotcha.
Yeah. Yeah. So glycolysis is anaerobic. There's no oxygen needed. It turns it into one glucose turns into 2 pyruvates.
Okay. Okay. I'm so
Good?
nervous about this. I'm nervous about this test coming up, but let's do it. Like whatever. I'm gonna do the
Yeah.
best I can. So
Yeah, you're doing pretty good.
okay.
You know, I can tell you're a little unsure about certain topics, but your thinking is really good. You're able to think on your feet, and you're like lysis, and you went to hydrolysis, which is to break down water.
With water.
So then why wouldn't glucolysis be breaking down
glucose.
Yeah, or glyco be breaking down glucose. Exactly. All right. And you know, Genesis, coming back to this, Genesis is the creation, right?
Yeah, at the beginning. So that's
In
how
the beginning.
right.
Yeah. Okay.
Okay.
What are the products of aerobic respiration? So when we got Krebs cycle and the electron transport chain. What's that?
Right. I said oxygen, of course.
Well, we don't make oxygen. We use
Oh,
oxygen.
you mean the products? The products.
Yeah. What do we make? We use up oxygen in the process.
ATP.
Yep.
Would you just, am I to keep going? Because I'm thinking like you do get some CO2,
Yep.
CO2 from that.
Yep.
So
Then it must be all of the above.
it must be all of the above because you're going to get some
Right.
water as well.
Right. Yeah. Water is the last thing that gets produced as
Okay.
in the electron transport chain. That is the very last thing that gets produced. But you're
Okay.
absolutely right. Yeah, we produce ATP in both the electron transport chain and the Krebs cycle as part of aerobic respiration. But we only produce carbon dioxide in the Krebs cycle.
Okay, in the Krebs cycle. Okay.
And we only produce water in the electron transport chain.
Electron transport.
Yeah.
Okay.
Good. Yeah. So even if you weren't sure about water, couldn't remember where water comes in, it's like, I know ATP.
Oh, it's coming in.
Yeah. And then carbon dioxide, so it's got to be all the above. Right.
Right.
Okay. So how many total ATP does glycolysis make? How many total? Not net, but total.
How many total does glycolysis make? And glycolysis, the breakdown of glucose. Ooh, I want to say, I don't know why 2 is like just there for me, but I could be
So
wrong.
it makes a net of 2,
Okay.
but it requires 2 to get started.
Okay.
So if we
a
use
cycle is 4, right?
exactly yeah, glycolysis will make 4, but because we use 2 to get the process going, we end up with a net of 2. So that's why I emphasized total.
Okay. It takes what a complete cycle makes 4. Okay.
Yeah. So breaking down glucose into pyruvate will create 4 ATP, but because we use 2 to get the thing started, we end up with the
4.
Yeah. Right.
Okay.
So if you were to be asked this question on the exam, you need to be careful to see what they're stipulating.
What they're asking, right.
Is it the total or is it the net?
Gotcha.
Yeah.
Okay.
All right, good. I don't have any power. That's what's going on in my house. All right. So the role of the electron transport chain is actually to move the hydrogen ions into the intermembrane space. All right. So I'll have to correct Shannon on that, give Shannon some feedback. All right, so which process produces the most ATP? Is it glycolysis? Is it the Krebs cycle? Is it the electron transport chain? Is it the phosphagen system? Well, we've gone over this a few times. We know that glycolysis produces 2. We know that the Krebs cycle produces 2, but the electron transport chain and what it's setting things up to do is really where the payoff is. And I probably should, when I call it the electron transport chain, I probably should call it oxidative phosphorylation, because it's not just the electron transport chain, because as I stated in my previous question, it's basically moving hydrogen ions into the intermembrane space, and it's ultimately the ATP synthase that is making the ATP. So this is kind of a funny answer. And I kind of prefaced it with saying that you can't say the electron transport chain, because really the electron transport chain is moving electrons into the intermembrane space. So the correct answer would be the Krebs cycle. Krebs cycle is giving us the most ATP directly with 2, but then it's also producing all of that NADH, which is setting us up for producing more ATP later. So probably not the best question in the world, but that was my reasoning behind it. So, all right. So where does the body store most of its glycogen? Is it in the liver and the pancreas? Is it in cardiac muscle and skeletal muscle? Is it in the gallbladder and the liver? Or is it in skeletal muscle and the liver? Well, hopefully you know the liver. We've got 2 choices here. It's either liver and pancreas or liver and skeletal muscle. And I'll tell you, the pancreas doesn't store too much. So the correct answer is skeletal muscle and the liver. All right. I don't know that we saw anything that looked like this in the lab, or certainly not in my notes, but I did mention it in my notes. So I want to address it here. So the body is only capable of using glucose to make ATP, but there are other simple sugars that will be allowed to enter into the bloodstream, which means that the liver is going to have to do some work on those to turn those into glucose. So which of these simple sugars is the liver going to convert into glucose? So I give you pictures here, and I expect you to be able to define what a monosaccharide is. Now, if you're thinking through this, you might know that mono means 1. And there are only 2 pictures where we see one of those sugar rings. So here we have 2 sugar rings right there. Here we have 2 sugar rings right there, and another 2 right here. So it's probably not any of these. And the answer would be galactose, which we get from milk, and fructose, which we get from fruits. So the answer would be fructose and galactose. So this is only a brief mention in my notes, and I said that the body only uses glucose to make ATP. But there are simple sugars, a couple of them, that can be entered into the bloodstream from the intestinal tract, but the liver will convert them into glucose. And those 2 are galactose and fructose. All right, so when the body breaks down lipids, this is known as, well, you're looking for the word that has lysis in it. And in this case, it would be lipolysis. All right, after the body has used up glucose stores, what does the body use next for energy? So which macronutrient is going to look to next? Is it going to go to ketones? Is it going to go to amino acids, lipids, nucleic acids? What are we looking at here? Well, basically, once we've used up glucose, and that actually includes using up ketones, the next thing that the body's going to go to is lipids. So your body's going to use up your carbs first, your glucose coming from your carbs, and all the glucose is formed in the body, and then it'll next turn to fat stores. The body can break fatty acids into this molecule, which can then enter the aerobic respiratory cycle. So what molecule is that? What can we break our fatty acids down into? Ketone bodies, lactate, acetyl Coa, or urea? Well, hopefully you remember that it is that 2-carbon molecule known as acetyl Coa. So a fatty acid is basically a long carbon chain with hydrogens attached to it. And then at one end, there's going to be some oxygen. And so it becomes really easy just to take a couple of those carbons and just snip them off, and then put a coenzyme on the end of it, creating acetyl CoA. And the reason that fatty acids can very quickly overwhelm the aerobic cycle is because we can create, if you have a fatty acid that has 16 carbons in there, you might even be able to get 8 acetyl CoAs out of that one fatty acid, and that's a lot, because typically we only get 2 acetyl CoAs from every glucose that we break down, but for every fatty acid we break down, we can get upwards of 8 acetyl CoAs. So we can very quickly overwhelm the Krebs cycle intermediate oxaloacetate, that 4-carbon molecule that our 2-carbon acetyl CoA has to merge with to form the first thing, which is citrate. So what's going on with that? What do hepatocyte, skeletal muscle, and cardiac muscle have in common? They all prefer glucose for ATP production. They all prefer fatty acids to make ATP. They all prefer glycogen to make ATP, or they prefer amino acids to make ATP. Again, this was mentioned, I think I talked about it twice in class, and these cells, particularly skeletal muscle and hepatocytes, I remember I did talk about those 2, they all prefer fatty acids to make ATP. In fact, they prefer medium chain fatty acids to do that. All right, so when the body takes glucose and turns it into fat, what's that called? It's called lipogenesis. Now, I know that when we take protein and we make glucose with it, we call it gluconeogenesis, but we don't include the neo with the lipo for some reason. All right, linoleic acid is an example of, well, I only mentioned 2 of these. I mentioned linoleic and linolenic acids. And so I'm asking you about linoleic acid. And I said that you need to eat these. And the reason why is because they are called the essential fatty acids. So the prefix essential, when we're talking about amino acids or fatty acids, basically tells us that the liver, as amazing as it is not capable of using other inventory resources to put together fatty acid that is linoleic or linolenic acid. It can make a lot of other fatty acids that we need from other sources, but it can't make linoleic or linolenic, and both of those are essential fatty acids. But the good news is that those are easily gotten in the diet. They're found in a lot of the foods that we eat, so it's almost, most people don't even have to worry about having any sort of a deficit with the essential fatty acids because, like I said, they're found everywhere. All right, during times of prolonged fasting, the body uses fatty acids and possibly amino acids to produce ketone bodies. And I'm just giving you a statement. And then I'm giving you some terms. So let's see, I think the question would be, what is that called? Is it called lipogenesis? Well, we're using fatty acids, so we're not making fatty acids, so it probably wouldn't be that. Gluconeogenesis? No, because we're not making glucose, we're making ketones. Would it be ketogenesis? I'd go with that answer. It's got keto in it, and we're making it. So yeah, ketogenesis. So prolonged fasting basically means that we've used up our rapid fuel source, which is going to be glucose. And so now we have to turn to fatty acids and then eventually amino acids to get there. All right, so which molecule does the body use to make fatty acids in lipogenesis? So we're going to be making fatty acids because the body does that. So we're going to start with pyruvate. Is that what we're going to do? We're going to start with ketone bodies. Well, wait a minute. That's coming from, no. Is it going to be acetyl CoA? Or is it going to be lactate? Well, it's acetyl CoA. And this is really an important pivot point in a number of different chemical processes in using energy and differentiating between using energy and using food as a storage, fuel storage. Because what can happen is that we can take glucose and divide it, break it down into pyruvate, and then take pyruvate and break it down into acetyl CoA. We can take fatty acids and break them down into acetyl CoA. So in this way, we have an easy access to the Krebs cycle with both glucose and with fatty acids. But if we're in a time of plenty, and we don't necessarily need that acetyl CoA to enter into the Krebs cycle because we got a bunch of that floating around, the body can actually use acetyl CoA and start stringing them together to make these long carbon hydrogen chains called fatty acids. So because we can take glucose and convert it into acetyl CoA and then pivot and then turn that into fat, that's a reason why carbs getting metabolized into fat happens really easily. All right, the breakdown of which molecule creates ammonia. Ammonia is NH4. That's the ammonium ion. NH3 is ammonia. And we talked about that, and I talked about how the amino acids are put together and that they have that amine group on there. The amine group is going to be nitrogen with 2 hydrogens, but when we pluck it off, and we are going to pluck it off of the amino acid molecule because it shows up in every amino acid. When we do that, it's going to join up with a hydrogen that's floating around nearby and create the ammonia molecule. Sometimes it can pick up 2 hydrogen ions, and it will become the ammonium ion, which has 4 hydrogens and bears a positive charge. But either one of those is going to be a problem, basically, because it can easily, ammonium ions can convert easily into ammonia. All right. So the body breaks down ammonia into this molecule because we don't like ammonia floating around. And this is something that we can move out into the urine fairly easily. Hopefully you said urea, right? So we metabolize amino acids, we get that ammonia, and then the liver converts ammonia into urea. All right, this state occurs after a meal when insulin is being released, sugars and amino acids are entering the bloodstream, and fats are entering the lymphatic system. by way of those lacteals. So do we call that the absorptive state, the post-absorptive state, the digestive state, the fasting state? What do we call that? Well, hopefully you recognize that this is the absorptive state. So insulin being released is telling us that we're triggering the movement of these food particles, this inventory of food particles into the cell. So we're absorbing those food particles. We've done with the digestion of it. We've broken them. We've done all the catabolic reactions, and now we're going to basically absorb those monomers into our cells. This state occurs when the rate of anabolism is greater than that of catabolism. Absorptive state. Talked about that in class. All right, this state is when food has been digested and stored, and we are all done. Post-absorptive. So technically, we're not going to have super high blood glucose, we're not going to have a lot of nutrients floating around. Everything's been tucked into a cell, and now the cell's busy doing its little thing. Right. During starvation, what is the last macronutrient that the body will utilize to produce glucose? So we start off with glucose, and then we end with breaking down proteins. Now let's think about that. So the body, we already talked about how easy it is for fat to be broken down into acetyl Coa and then go into the Krebs cycle, right? And so that's easy. And then we haven't talked a lot about proteins being broken down, but the deal with proteins being broken down is that many of our body structures are made of protein. So once the body has, the body's going to want to preserve protein in order to preserve body tissues, basically. That's it. So once we've exhausted all supplies of glucose, once we've basically ripped through most of the fats that are available, now we're going to start turning to the body proteins. And you'll see muscle wasting. And with muscle wasting, you're always worried about compromising the heart. And it's not uncommon for anorexic patients to end up dying of a heart attack because basically the heart muscle's been degraded and is now weak. And with that, we are done. All right. Thanks for watching. And I'll get out of here. And I'll stop recording.